Welcome dear student. Today we will start a new chapter in science, that is chapter 4, current, electricity and magnetism. Now let's start with the chapter. Now let's see, can you recall first? Now students, which constituents are present in an atom? So atom constitute of proton, neutron and electron. So these are the three main constituent of the atom: proton, neutron and electron. Now students, here you can see an structure of an atom. See, you can see a blue colored protons, yellow neutrons and the red one electrons, which are revolving around the nucleus. So proton and neutrons are present inside the nucleus and electrons are revolving in the orbit around the nucleus. So an atom has same number of positively charged protons and negatively charged electrons. That means protons and electrons are equal in atom. Now students, an atom has same number of positively charged protons and negatively charged electrons. So an object doesn't show any charge, though its atom contain charged particles, means they are charged but they are not give current to us. That means it is hidden. Okay, so therefore we can say that plenty of electrical charge is filled in the objects around us. They have electrical charge but they doesn't show to us. Now students, what will happen when a glass rod is rubbed on a silk? So when a glass rod is rubbed against or rubbed with the silk cloth, then some of the electrons from the glass rod get transferred to the silk cloth. That means glass rod loses some of the electrons, and that loose electrons are acquired by the silk cloth, and thus this losing and sharing of the electron, losing by the glass rod and acquired by the silk cloth, and thus the glass rod becomes positively charged while the silk becomes negatively charged. As you can see in the picture, the glass rod has positively charged particles and silk cloth has negatively charged particles. Now students, how do objects get charged? So an electrical charge is created when electrons are transferred to or removed from an object, because electrons have a negative charge. When they are added to an object, it becomes negatively charged. When electrons are removed from an object, it becomes positively charged. So this is how the objects get charged. So in an object, when the electrons are removed from an object, it becomes positively charged, and when the electrons are added to particular object, that becomes negatively charged. Now students, here one question is there: what are the static and moving charges? Now students, when all the atoms of an object acquire the electric charge, the object as a whole becomes electrical charge. So now let's see what are these two charges: static charge and moving charge. Now static charge is electric charge that has accumulated on an object. It is called static. Why? Because the charges remain in one area rather than moving or flowing to another area. While now let's see the moving charge. If the charge moves, then it is said that the object has moving charges, and if a charge is moved, the electric field is moving with it. So students, what is the static charge? It is accumulated, or it will the charges which remain on a surface only, or in one position only, we can say. Okay, and moving charges, the charges which can move. Okay, they are not stationary. So it's not stationary means moving charges, and static charges are stationary charges. Be they will be at one place only, or on surface only. Now moving charges get transferred from one object to the other. Why? Because when the charge will move from one to another, then it will from one object to another, and these are negatively charged. Moving negatively charged particles are the electrons. So the electrons are moving from one object to the another. Now, can this negatively charged be made to flow? Now, negatively charged means electrons only. Now, students, in a battery, the electrons are considered as a negatively charged and are attracted to the positive end of the battery, a positive end of the battery, and repelled by the negative end. When the battery is hooked, then the electrons flow through it. Therefore, they flow from negative end to the positive end of the battery. Okay. Can electricity be made to flow like water flowing from higher to lower level? The amount of current can change, but it will always flow from one point to another. So although electrons would flow from negative to positive, by convention, physicists refer to conventional current as a flow from high potential to low potential, that is from positive end to the negative end. Now students, we get current electricity when the electrons in an electrical conductor are made to flow. Now when we will get the electricity? When the electrons will move from one end to the another end. It means from the negative to the positive terminal, then we get the current electricity in an electrical conductor. Now what is the electrical conductor? The which can carry the charges, that is positive and negative. So current electricity will produce due to the flow of electrons. Now let's see the current electricity. Now students, a large current flows when lightning takes place from a cloud to the ground, while sensation is felt by us due to microscopically small current flowing to the brain. You are aware of the current flowing through wires, electric bulbs, and equipments in the houses. In an electric cells of a radio or in a car battery, a current is produced by the flow of both negatively and positively charged particles. Now let's see the electrostatic potential. Now students, water or a liquid flows from a higher level to a lower level. Heat always flows from a body at a higher temperature to a body at a lower temperature. Similarly, there is a tendency of the positive charge to flow from a point of a higher electric level to a point of a lower electric level. This electric level deciding the direction of flow of electric charge is called as the electrostatic potential. Now let's see the potential difference. Now students, similar to the height of a waterfall, the temperature difference of a hot and cold bodies, the difference between the potential of 2 points, that is potential difference, is interesting to us. Now students, what is the potential difference? It is potential difference is the amount of work energy. It is an amount of work energy required to move an electric charge from one point to another point. That means it is a type of energy which required to move an electric charge. Electric charge means moving of electrons from one point to the another point. Now here we have to do one activity. Now students, let's try this. Take a connecting paper, connecting copper wires, and connect the circuit as shown in a figure 4.1a electrical circuit. No current is seen to flow in the bulb. Now connect in the same circuit a 1.5 volt dry cell available in the market as shown in the figure number 2. Now it will be realized from glowing of the bulb that a current is flowing in the circuit. Electrons in the wire flow due to the potential difference between the two ends of the dry cell, and these flow from, that means these electrons will flow from the negative terminal of the cell to the positive terminal of the cell. Conventional current flows in the opposite direction. Now what is conventional current? That means the flow of the current from positive to negative terminal. That means flow of the electron from positive to negative terminal. This is conventional current. So conventional current flows in the opposite direction and is shown in the figure by the sign of an arrow. You can see in the figure number 2 how arrow is indicating, that means flow of electron from positive to negative. We will learn about an electrical circuit later in this chapter. Now in first figure, now students, in first figure there is no current as there is no potential difference in the absence of any surge. That means in figure number 1 no cell or no cell is present, that's why no potential difference is created, and current start flowing in the circuit as soon as potential difference is applied. Now students, you can see two pictures, 4.1a and 4.1b. Now in first circuit no current will be flow. Why? Because there is an absence of cell. If the cell is not connected in the circuit, or if the cell is not connected in the circuit, the current will not flow. But in second figure you can see the arrow indicating the flow of electron from positive terminal to the negative terminal. That means the current will flow, or the potential difference will created only in the presence of the cell in the electrical circuit, and that's why by connecting the cell or battery the bulb will light up. Now students, the unit of potential difference in SI system is volt. We will learn about it. Now students, how can we measure water flow emerging from a pipe? We can find it from the amount of water liters coming out in a specific time period. How then is the electric current is measured? Electric current is measured by the amount of charges flowing in a wire for a specific period of time. Now students, electric current is produced due to the flow of charged particles. Charged particle means negatively charged electron, and electric current comes from a motion of electron, that is from positive to negative terminal. Electric charge flowing through a wire, unit current. The SI unit of the electric current is coulomb per second or ampere, and 1 ampere is equals to 1 A, capital A, which is equals to 1 coulomb per second, or ampere is equals to 1 coulomb per second. And electric current is a scalar quantity. Scalar quantity, that means it has only magnitude or a mass. So students, I hope you all have understood, and next part of the lesson we will continue in the next session.